I'm very pleased to introduce our next keynote speaker, Lukas Biewald. So Lukas has been a great supporter of ODSC and our mission. He's also the CEO and he's the CEO of Crowdflower, a successful startup based here in San Francisco that specializes in data enrichment and crowdsourcing. And Lukas is very well known for his community spirit. I'm going to have to embarrass him here a little bit and mention just one of his good, name just one of his good deeds. He won the Exploration Prize for creating an app which allows users to perform small tasks that assist refugees and people in developing countries. And Lukas, okay, maybe I'll embarrass him twice. So Lukas has also been listed as one of the top 30 entrepreneurs under 30 by Inc. magazine. Please welcome Lukas Biewald.
Thanks. Can you hear me? Yeah, great. Awesome. So I'm the CEO and founder of Crowdflower, and before that, I did a lot of work in data science. And as Crowdflower, we started back in 2009, and we've been selling a data enrichment platform to data scientists. So we've been doing this for a long time, and I could not be more excited to see all the things that are going on right now. That 1,000 people showed up on a weekend to learn more about data science. I think it's just awesome, the things that are happening. And so I want to talk a little bit about where data science has come from, because I think a lot of us have been doing it for a long time, long before it was even called data science. And talk a little bit about where we are today, what's the exciting things going on, especially in startups and in commerce, because I figure there's lots of people talking about open source and nonprofit stuff, but I want to give kind of a company perspective, and then talk a little bit about where things are going. So it's obvious that data science has become the hardest to hire job. We struggle to hire data scientists. So many people are learning data science. It's fantastic. And I love that companies are seeing the value of data, but it wasn't always like that. I was selling to data scientists back in 2009, and there really were no data scientists. And I remember when DJ wrote this article in Harvard Business Review back in 2012, calling data science the sexiest job in the 21st century, I thought, wow, is data science overhyped? But that was actually 3 years ago. And since then, DJ got hired to be Obama's chief data scientist, right? I mean, I don't think there were any companies with a chief data scientist just a few years ago. Now our government hires a chief data scientist. And so folks ask me all the time, do you think data science is overhyped? And definitely Gartner thinks it is. So Gartner is an analyst firm, and they have what they call their hype cycles. They talk about the early technologies, and then they talk about the peak of inflated expectations, which is like this narrow range before the trough of disillusionment. And you know, this is a big analyst firm. They sell to executives and companies like IBM. And so even they think this is overhyped. They don't just list data science at the top of their hype cycle. They have 4 subcategories of data science. They have machine learning, they have natural language processing, they have speech translation, and they have citizen data science. So it's not just data science at the top of the hype cycle, it's kind of all the aspects of data science. So people always ask me, do I think data science is overhyped? And I'm not sure, but I do know that there's a lot of value being created. And one place that there's a ton of value being created is in the open source ecosystem, which I think a lot of you probably know about even more than me, but I'll say I'm thrilled that we use lots of these tools. But there's also an amazing business ecosystem that's starting around data science, and we tried to segment it to look at the different companies where data science is a really important component of their business. And we see really 3 big categories. We see data sources, data wrangling, and data applications. Inside data sources, we actually see 3 different, broadly, kinds of data sources. We see databases, applications, and third-party data. This is all the places you can go to get data. And maybe databases is the most exciting segment of this. I remember when I started my company, it was really a choice between Postgres and MySQL. And now there's hundreds of NoSQL options available. And this was really driven by data science, by people wanting to do new kinds of analytics. And then there's third-party data sources from Factual to GNIP, where people have built whole companies around selling data for data analytics. And Forrester actually predicts that just the NoSQL market, just a small piece of this, is going to grow to $3.4 billion in 2020. These companies really didn't exist. These technologies didn't exist 10 years ago. And there's millions of tools for building all kinds of graphs and visualizations. So every company now buys a BI tool. There's data collaboration tools where you can present charts and graphs not just for executives, but for other data scientists, for your customers, for all the constituents in your company. And some people ask me, hey, do these graphs and dashboards really matter? I actually had a customer tell me that due to better data analytics, they increased their revenue by $40 million in 2014. So this is real money and a really big deal for lots and lots of companies that you wouldn't think of as technology companies. And then machine learning is the world that I come from and near to my heart. I remember when I was coming out of school, there weren't a lot of jobs in industry in machine learning. And a few years later, Jeff Hammerbacher said famously, the best minds of my generation are working on making people click on ads. That sucks. Which I thought was actually really, really true and kind of a painful thing at that time. But it's completely changed, right? There's all kinds of companies that work on machine learning in all different aspects of industry. And we expect that the market will reach $15 billion in 2019. That's just 4 years from now. And then data wrangling is, of course, the world that Crowdflower lives in. It's the glue that connects the databases and the data sources to the insights and the models. And it's kind of what we don't learn in school but spend most of our time doing. And I'll say the reason that I like inhabiting the space is exactly because 67% of data scientists say that this is the least interesting and most time-consuming part of their job. And so it feels good to help people with the part of their job that they don't like. And so what's going on in Silicon Valley? I mean, you guys have probably noticed around here that funding is at an all-time high. In fact, funding of tech companies is almost at 2001 levels in inflation-adjusted dollars. And data science probably didn't get any funding back in 2001, and nobody tracks data science funding specifically, but there are a bunch of things that have happened really recently that matter a lot. So one is that Hillary Mason got hired by Excel as its first data scientist in residence, right? So they didn't just fund a data science company, they hired a new position called data science in residence. IBM Watson just launched a $100 million VC fund for machine learning startups. Data Ventures closed a fund to back data analytics startups. Data Collective has raised 3 funds, I think, in the last 3 years for data-backed startups. And Workday didn't just try to hire data scientists, they launched a whole venture fund that they claim is to give them access to top data science talent, which I think is an interesting strategy, but really good for everyone in this room. And so, you know, I run a VC-backed company, and I think anyone that's done that knows that with raising tons of money comes tons of expectations. So I think a lot about what does it take to make data science real and not have kind of a data science winter on the horizon if it doesn't meet the expectations that people have. And I think there's one single thing that's critical to data science success, which is probably obvious to everyone in this room, but maybe not obvious to everyone outside this room, which is that data science starts with data. So if you have lots of data, you're likely to be successful. And if you don't have data, you really can't do data science. So a simple example, I ran a categorization job, and just by giving it slightly more training data, going from 10,000 rows to 20,000 to 40,000, I was able to get significant improvements in the quality of my models. And I actually think companies are starting to realize this too. So if you look at what smart companies are doing, they're basically buying data sources and they're open sourcing their algorithms, which is interesting. I think the algorithm used to be thought of as companies' secret sauce. So we see IBM bought Weather.com for its data for over $1 billion. They bought a healthcare company for its data for over $1 billion. Meanwhile, recently Facebook open sourced its machine learning algorithms. Google open sourced its machine learning algorithms just this week with TensorFlow. And then Microsoft just yesterday open sourced their machine learning library. So I think we see it in maybe not what companies are saying, but what they're doing, which is buying data and giving away the algorithms. But this is exciting for data science profession, right? There's so much data being created every day. Unfortunately, it's often inside of walled gardens. So you can go to any of these companies and get a job analyzing this data, but you can't always get access to it. So everything that we do is now being tracked, and companies are trying to hire you guys to figure out what to do with that information. But that makes me even more excited that our government is actually opening up data so that anyone can use it. So our government has made a major open data push, and 40 states have followed suit with their own open data projects. In fact, the city of San Francisco also has an open data project. And this has created lots and lots of innovative things that really help people, right? So there's LearnSprout that tracks education outcomes, makes teachers better. There's StreetCred that helps keep police officers safe. There's Public Art Finder that helps you find interesting art. So just by opening up the data, they've created a whole ecosystem of useful apps. And I just want to give Code for America a shout out, since they're really at the forefront of pushing this stuff. At Crowdflower, we also open up data because we think it's really important. We've released over 250 million rows that anyone can use to benchmark their models, to train classifiers. But I think just saying data science needs data is a little bit of an oversimplification. So to get slightly more specific, I think that data science needs rich data. So Nate Silver said this so well, that it's not just big data, it's something much better, rich data. By rich data, I mean data is accurate, precise, and subjected to rigorous quality control. And so I find this in my day-to-day experience too. So I took the same classifier and fed it 90% accurate data, and got a pretty mediocre classifier, fed it 95% accurate data, and it got a lot better. Gave it supposedly 100% accurate data and got the error rate down to 4%. So that was much more powerful than any choice of model. Actually getting it better data was really the most important thing. And so then I wonder, okay, this is really exciting. What's kind of the next step? Where are we going? What holds data science back? And I actually think that it's in this kind of 4% lingering error rate. Because I actually picked a pretty easy example here. I picked an easy classification job. Lots of other classification jobs have more like 20% error rate. And businesses can't use that for most things that they want to do. There are certain cases where they can, but I think most of the time, executives kind of look at that and say, you know what, 20% error rate, I'm not gonna use machine learning, I'm just gonna bypass this whole process. And so I think where things are going is that we need to figure out in the short term, before the singularity supposedly comes, how to deal with this, right? How to solve this lingering error rate. Because it's impossible to get this error rate down to 0% with the technology available today. And so I'll be talking about this a little later, but just to give a preview, I think an exciting thing is in the way that automated cars have gotten better and better. It's not like one day we just see automated cars on the road. We see them replacing drivers in pieces. So the Tesla takes over on the highway. It takes over in simple cases where it knows that it's very, very sure it can automate it. And in snowy conditions, or if that car in front of you veers off into a ditch, it forces the human driver to take over. So it creates a very reliable system and a better system using partial automation, using human-in-the-loop computing. And chess, one of my favorite games, computers beat humans actually 10, 15 years ago. I remember when Deep Blue beat Kasparov was a big deal. But what I actually didn't know is that humans and computers still play chess together. So if you actually wanted to build the best possible chess algorithm, you would still use a human and a computer together. So there's actually a group of super cool guys who play this game called advanced chess, where they have a human operating a computer, and they use their human intuitions for situations where humans are good, and they switch over to the computer in many situations where the computer is actually stronger than humans. So I think we can apply this to pretty much everything that businesses do, and I think that AI-human hybrids are coming in a big, big way. And I'm super excited about that. I think it's going to make lots of machine learning go from a research project to a real thing that businesses do. And I'll actually be talking about that later today, so a little bit of a preview for my talk later if this is interesting to you. Thank you.